want to ask some queries, then you can unmute yourself at any point of time and ask queries. Also, one request I make all of you, please make these sessions interactive. Okay, so by actively participating in the course, right? So it means whenever I ask something, please try to answer that. If you have some query, please try to raise it. Okay, you can speak up. Instead of typing it in the chat box, you can speak up and ask that query at any point of time. If it is some general query that is not relevant to the current section, then you can postpone that query to the end of the session, right? If it is something relevant to the current session, that means the ongoing topic, then you can raise it whenever you got that doubt. Whenever you couldn't follow something also, you can ask me to repeat. So I'll be happy to repeat that. So, so please do make this session interactive and interesting. I hope you would enjoy the course by doing so. All right, so let us start the session. So in this session, we're going to see the introductory part, as I have mentioned to you already. So we'll be discussing what is data science, what is machine learning, why is that important, and what are the different applications, what are the different paradigms in the machine learning. All right. So this is the agenda for this particular topic. We're going to discuss introduction to the data science. What is data science? Why do we need the data science? And what do data scientists do? And what is our concentration in data science? So data science is like a multidisciplinary field. Theories and techniques from various fields have been combined together to learn the patterns from the big data, right? So we'll be focusing on particular part of the data science, which is the machine learning part. So we'll be discussing the introduction to the machine learning. So what is learning? What are the different paradigms in the machine learning? We'll be briefly looking at them. Then we'll be covering them in detail in the coming sessions. So this is the agenda for this today's session. So I hope my voice is clearly audible. If you have any problem with my voice, please let me know so that I can adjust the audio. Okay. I hope the voice is clearly audible.
Yes.
Yeah.
Yes, sir.
Yes, sir.
And
Clear.
my screen is visible, right? In the full screen mode.
Yes,
Yes,
sir.
sir.
You can see the movement of the slides also, isn't it? Currently, I'm in the outline slide.
Yes, sir.
Yeah, fine. So, okay, let's begin the session. Fine. So, as you all know, let me talk about what is this data science first of all, and why do we need this data science? Okay. So before that, data science is all about the data, right? Right. So as you all know, that the modern life is web supported. I hope all of you agree with me, because we rely on the internet for so many things in our day-to-day life, right? So, like for example, we attend classes online, we play games online, we read news articles online, we read books online, and we shop online, we reserve for the cab online, we order for the food online, we plan for the tour online, as well as we engage in various other activities with the help of World Wide Web, isn't it? So this has made the internet become part of our daily life. Therefore, it is natural that the competition among the vendors offering various services and our interaction with these systems leading to explosive growth of the data. Right? So currently we are living in a data era where a huge amount of data is collected and stored every day, every minute, right? I can show you that the kind of data growth that we have in the today's world. In the face of this growing quantity of the data, this machine learning or data science related algorithms became inescapable, because they process the data to determine the patterns and use these patterns to help the user with various applications. Like we have different kinds of data, like social data in terms of likes, dislikes, comments, or the uploads, right? We have the mission data. Nowadays we have the sensors everywhere in the IoT world, right? So we have sensors are placed everywhere: smoke sensors, temperature sensors, humidity sensors, cameras. They're fixed everywhere, and 24/7 they're collecting the data, right? And this type of data is expected to grow exponentially as the Internet of Things grows. And it is expected that many of the IoT devices are coming up in the next few years, right? So similarly, we have the transactional data in terms of the financial transactions that we make. Nowadays, we are making so many UPI payments, right? So credit, debit transactions, or the receipts, invoices, payment orders, lots of data. And not only that, we have the huge amount of data, we have the varieties of data. We have the we have the image data, video data, audio data, text data, transactional data, or XML data, relational data, graph data. So the data is in various forms. There are wide varieties of data, right? In the face of this growing quantity of the data and wide varieties of the data, machine learning algorithms became inescapable. So we may be using these machine learning algorithms dozens of a time a day without even knowing that they are the machine learning algorithms or the data science algorithms. So let me list out few of the algorithms to make you realize this. For instance, when you upload a photo to the Facebook, it gives you some suggestions to tag your friends, isn't it? So it employs a machine learning algorithm for the face recognition and the tag suggestion. Similarly, when you type something in the Google predicts the next possible word using the machine learning algorithm while you are searching something on the Google. Similarly, you might have observed that Google Translate or the Facebook Translate utilizes this machine learning algorithm to translate the text from one language to the another language, right? So all this, the technology behind that is the machine learning. And similarly, YouTube uses the machine learning algorithm to exploit the user data and feedback to personalize the recommendation. Like when you like something on the YouTube, or when you dislike something on the YouTube, or when you skip watching something on the YouTube, YouTube learns from it and makes the recommendation based on your preferences. So the learning is continuous, and this recommendation evolves with your preferences to make your experience with the YouTube more enjoyable. So everywhere we are using this machine learning algorithms at lots and lots of places, but we may not be aware that the technology behind that is the machine learning algorithms. So we'll be exploring all these varieties of algorithms, machine learning algorithms, and the data science problems, machine learning algorithms, and also the different applications of this machine learning and data science. Also, we're going to explore as we proceed. Okay, so I said that there is a huge amount of data. How much? How much of data we have in the current in the today's world? Okay, so the amount of data that we have in today's world is enormous. Lots and lots of amount of data. So before we're gonna see the statistics, let me show you some website to make you realize the kind of data's growth that we have in today's world. Okay, there is something called thinkful.com blog. Okay, so I hope you can see my screen that I have opened one website, thinkful.com. You can see that, right?
Yes.
Yeah. So you see here, let me show you this speed. Since you started reading this website, it means few seconds might have clicked on the site. You see that 7,000 minutes of video have been uploaded to YouTube. By the time I read it, it is another 1,000, another 2,000, right? So 2,46,000 tweets have been made, 27,000 photos were posted to Instagram, and 2,80,000 Facebook posts have been liked, and 2,85,000, no, it's not 2 lakh, it's 30 lakh. 30 lakh Google searches have been made, and 1 crore 44 text messages have been sent. This all happened within few seconds. Imagine that what kind of data that we are collecting within a minute, within an hour, within a week, within a month, and within a year, right? So there is a tremendous amount of data's growth, right? In the face of this growing quantity of the data, can we make some meaningful patterns, or can we draw some meaningful conclusions out of this data? Can we use this data to make or to analyze or to um, draw some meaningful patterns from the data, and we use these patterns to develop various applications, right? That's what all the data science deals about, right? So let me go back to the slides. So I was in this slide that I was trying to demonstrate the kind of data that we have in today's world. So the amount of data is enormous, and the world was estimated to be 44 zettabytes at the beginning of 2020, right? And by 2025, the amount of data generated each day is expected to reach 463 exabytes globally. Can you imagine 463 exabytes, right? So exabyte means 1000 petabytes. Petabyte means 1000 terabytes, right? So you can imagine that 463 exabytes, it means it is close to the zettabyte, right? So Google, Facebook, Microsoft, Amazon store at least 1200 petabytes of information. And the world spends almost $1 million per minute on commodities on the internet. Okay, and by 2030, 9 out of every 10 people aged 6 and above would be digitally active. So you can imagine the kind of data that they generate. They're digitally active once they're digitally active. And over 2.5 quintillion bytes of data are created every single day, and it's only going to grow from there. So it is estimated that it's true that 1.7 MB of data will be created every second for every person on the earth. This is 2020 statistics, right? So you can imagine the kind of data growth that you have, right? So we have seen also in that website. So we have lots and lots and lots of data. So what can we do with this data? What can we do with this data is the question that we're going to address, right? So can we draw some meaningful patterns out of this data? Or can we use these patterns to expand the business and business decision making? Or can we use these patterns to help the user from the information overload problem? Or can we use this knowledge extracted from the data to make the right decisions? So lots of questions, and the data scientist answer for all these questions is yes. Yes, we can use these patterns to make some meaning. We can use this data to draw some meaningful patterns out of the data, and we can use these patterns to expand the business or business decision making process. Or you can use these patterns to help the user with the information overload problem and recommend whatever that he likes, right? And you can improve the quality of the decision that the customer is taking by analyzing his or her preferences, right? So the data scientist answer for all these questions is yes, we can do all this. All right. So what is data science? So data science is the multidisciplinary area, right? That is theories and techniques from uh, various domains have been put together to solve this or to analyze the big data or to manipulate or extract or interpret the knowledge from the tremendous amount of the data. So various fields like the computer science, mathematics, statistics, data mining, artificial intelligence, machine learning, applied statistics, applied mathematics. So theories and techniques from various multiple disciplines have been put together to to draw some meaningful patterns from the tremendous amount of the data. All right. So that's about the data science, right? So that's what is the data science. So why do we need data science is the question, right? So simply because uh, we have some business intelligence tools earlier, simple business intelligence tools like the Excel, those kind of tools. Simple business intelligence tools are not capable of processing the huge volumes and the varieties of data. In today's world, we have the huge volume and varieties of the data that we have already seen, right? So we need some tool that could analyze, that could process the huge volume and varieties of the data, right? And we need to understand the requirements of the customer and make the recommendation accordingly. That will improve the sales. You might have seen that when you are browsing something on the what is that Flipkart or Amazon or Meesho, it shows you some recommendations, okay, and most often you tend to buy them. It's because it's not just like that it is recommending something to you. It is analyzing your preferences and coming up with some recommendation, right? So this is basically helping you with the information overload problem. So lots of items, if you take the Amazon, there are thousands and thousands of items available on the Amazon. Why is it showing you very few items that you may like, right? So through this way, it is also improving the sales of the provider. And at the same time, it is helping you with the information overload problem, right? It's helping you to take the better decisions, all right? And similarly, it helps in the decision making, like for example, self-driving cars, and it helps in the predictive analysis, like for example, weather forecasting, and many more. Lots of applications of this data science, all right? So who are the data scientists? The data scientists are the key to realizing the opportunities presented by the big data, right? So they bring structure to it. They find the compelling patterns in it, and they advise the executives on the implications of the predicts, processes, and the decisions, right? So, so the data scientists are the key to realize the opportunities presented by the big data, right? They find the patterns from the data and use these patterns in the better decision making process, right? According to this Harvard Business Review, they said that data scientist job is the sexiest job of the 21st century. Why is it so interesting? Why is it so exciting? Job of the 21st century. Isn't it exciting if the output of our work directly addresses the customer's needs? Or isn't it amazing to tell the story from the data, right? Or uh, isn't it exciting to stay up to date with the kind of research that is going on in the area? So if you are a data scientist, you have to do all this, right? That's why it is so exciting, right? So there is an increasing demand and there are lots of opportunities, right? So the data scientists, they find stories, they extract the knowledge, but they are not the reporters. They find the stories from the given data, right? Because they analyze the data, they find stories from the data, all right? So what do data scientists do? Lots of things, lots of applications of data science, as I've mentioned to you already. National security, cyber security, business analytics, engineering, healthcare, travel, hospitality, what not, right? Everywhere it has got the applications. Okay, so here are some of the real life examples of the data science. So companies learn your secrets, shopping patterns, and the preferences, though you don't want to know them. Like for example, for example, we can know if a woman is pregnant or not, even if she doesn't want us to know, like from her shopping patterns or from her, I mean, the kind of clothes that she is purchasing or the kind of medicine that she is purchasing. From all this, you can interpret whether she is a pregnant woman or not. Once you understand that, yes, ma'am, do you have any query, Preeti Singh? Please mute yourself if you have no query. All right. So once you have this information, you can make the recommendation accordingly. You can make the recommendation that is suitable for the pregnant women, or you can make a recommendation of medicine or hospitals, whatever, right? So similarly, data science and the election. 1 million people installed Obama Facebook app that gave access to the information on the friends. Similarly, identifying and predicting the disease diagnosis, cancer detection, or tumor detection, or diabetes detection. We're going to see some of these applications in the with hands-on also, like the diabetic diagnosis. We'll be looking some application hands-on, and personalized healthcare recommendations, or optimizing the shipping routes in real time, robot navigation routes. Okay, um, give me a second. Or finding the next slew of world-class athletics, right? Stamping out the tax fraud, automatic digital ad placement, right? This we daily face that whatever site you open, you get some ad placements, right? Algorithms that help you to find love, like nowadays we see a lot of dating sites also, right? And predicting the incarceration rates. All these are some of the real-time examples of the data science. All right. And there, as I have told you, that data science is a multidisciplinary. and theories and techniques from various disciplines are put together to find some patterns from the big data, right? So various disciplines like mathematics and applied mathematics, applied statistics, programming, data mining, database, storage and management, machine learning, and discovery. So the main focus of this course is on the machine learning and discovery, although we'll be covering some of the programming part, some of the mathematics part, but the main focus is on the machine learning. Okay, so we'll be covering the programming part also. Python we'll be covering. We'll be covering some mathematics part also. We'll be covering the probabilities, concepts and the aspects of this machine learning. Okay, so this is the agenda for this data science. So let us see what is machine learning and what is learning. Okay, what is learning? What is machine learning? What are the different paradigms in the machine learning? So I hope you are following me. Are you with me so far? Are you with me
Yes,
so
sir.
far? Yeah.
Yes, sir.
Yeah. Thank you. So before we proceed to the machine learning, tell me what is learning? When do you say that you're learning something? Whatever it is. When do we say that we're learning something? So whatever it is, let's say the dance, music, or cricket, or cooking, whatever. So we say that we're learning something when the performance is improving with our experience. Like I can say that I'm learning dance if my performance at dance is improving with my experience. So I can claim that I'm learning music if my performance at music is improving with my experience. Or you can claim that you're learning cooking if your performance at cooking is improving with your experience. Or you can claim that you're learning cricket if your performance at cricket is improving with your experience. So basically, we say that we're learning something when the performance is improving with our experience. So the learning is equivalent to improving with experience at some task. So we humans have the ability to learn from our experience. You see that we learn not to touch fire because it gave us some bad experience. And we learn to celebrate in groups because it gave us some good experience, right? So imagine that you're trying to toss a paper to the dustbin. Okay, in the first attempt, you might overshoot your aim because of the too much force that you have applied. In the second attempt, you might reduce the force but miss the correct angle of your throw. So after few attempts, you might succeed in landing the paper to the dustbin. So why is this happening? This is because our brain is learning something and making changes after each and every experience, and thus improving the final results, right? So if the same thing can be implemented in a mission, that's called mission learning. As simple as that. Your ability to learn from the experience and making changes after and each and every iteration, if you're calling that as a learning, if you can do the same with the missions, that's called mission learning. If you can program the missions to improve from their experience, if you can program the missions to learn on their own, that's called mission learning. Mission is learning something. Mission is learning something and improving from its experience. Improving from its experience with respect to some specific task. Then we say that mission is learning the task. Mission is learning the task. That's called mission learning. So what is mission learning? Mission learning is improving over some task T with respect to some performance measure P and based on some experience E. Right? So mission is improving over some task T. How do you judge that? You need some performance measure. So with respect to some performance measure P and based on some experience E, then we say that mission learning this task T. Right? So what are these T, P, E, and how do we formulate a machine learning problem? Okay, so what are these TPE and how do we formulate a machine learning problem is the question. So let us see some of the machine learning problems, simple machine learning problems. Then you will understand how to formulate a machine learning problem within the setting of this task, performance measure, and experience, TPE. All right. So here are some of the examples. Let's take handwritten digit recognition. Here the task is classifying handwritten digits within the images. So given the images of the digits, we should be able to classify or we should be able to predict what digit it is. Is it 0 or is it 1? Is it 2 or so on? Is it 9? right? Performance measure. So how can you say that the machine is learning this task of handwritten digit recognition? How do you judge the performance of it? The percentage of digits correctly classified is the performance measure, and the experience is the database of handwritten digits with the given classifications. Okay, and similarly, if you take the robot self-driving cabs, you might have heard of it, right? So here, the task is driving on public four-lane highways using vision sensors, and the performance measure is average distance traveled before an error occurs. An experience here is the sequence of images and the steering commands recorded observing a human driver, right? So this is how we can formulate different problems within the setting of this, within the framework of this TPE, task, performance measure, and the experience. Okay. And so coming to the machine learning. So by now you might have understood that what is the machine learning. So machine learning is an application of the artificial intelligence. So what is an artificial intelligence? Artificial intelligence was designed with an intention of creating a human-like intelligence to do tasks or to perform tasks that typically requires the human intervention, right, or assistance, right? So now we are saying that this is an application of artificial intelligence. This is one kind of artificial intelligence that provides the system the ability to automatically learn, right? One of the intelligence that the human have, they have the ability to automatically learn from their experience, right? Similarly, here also the machine learning provides the system the ability to automatically learn and improve from their experience without being explicitly programmed. Like you see, that you take the desert classification problem. You need not explicitly define a rule saying that if it is round in structure, then it is zero. Or you need not explicitly define a rule saying that um, if it is a straight line, then it is one, right? So these kind of explicit rules you need not define. They have the ability to automatically learn without human intervention or assistance and adjust the actions accordingly, right? So let us see some of the examples to understand this concept. So let's take a classification of the swan versus the duck. You can see that from the image also you can easily guess what is the difference between the swan and the duck. For the swan, neck length is larger. For the duck, neck length is smaller, right? So, but you need not explicitly define these kind of rules, saying that if the neck length is larger, then it is swan, otherwise it is duck. You need not explicitly define in these kind of rules in your program. So these machine learning algorithms have the ability to automatically learn these rules from the given data, right? So that's the beauty of this machine learning algorithms. So let me give you one more example to understand the difference between the machine learning algorithms versus the classical algorithms, classic approaches. So machine learning algorithms versus the classic approaches. To understand the difference, let us take a small example. Okay, so could you follow me, or am I going too fast, or is this
Okay,
bit
sir.
okay?
No, sir, you are perfect.
Okay, sir. Yeah.
Okay, sir.
Yeah. Thank you. Thank you. So let us take some example to understand this. So let's say we want to predict the price of the house based on the characteristics of the house. Let's say that each house is described with the different characteristics or properties. Let's say the size of the house, size of the garden, number of bedrooms it has. So all these are the different characteristics or the features that describe the house. So based on these features, we should be able to predict what is the price of the house. So if you take the classic approaches, they assume that the relation between the price and the features of the house is known to us and it is explicitly coded. Like this, house pricing formula is known to us and it is explicitly coded in case of classic approaches. Like for example, price is equivalent to 1.2 times of the size of the house plus 0.7 times of the size of the garden and 3.1 times of the number of rooms it has. So this is the formula. It is known to us. It is assumed that it is known to us and it is explicitly coded. That's the classic approaches does. And what is the beauty of the machine learning approaches? To understand this, let us take the same example, but for the simplicity, to make this problem simplify it for you, I'm just taking only one feature, size of the house, and the corresponding output variable, which is the price of the house. Let's say the data is something like this. If the size is 100 square feet, then the price is $300. If the size is 300 square feet, then the price is some, let's say 200 square feet, then the price is $500. If the size is 300 square feet, then the price is some $700. If the size is 400 square feet, then the price is $900. Now a question to you, suppose if the new house is given to you for which you know the size but you don't know what is the price, and the task is to estimate it. Let's say the size of the new house is 500 square feet. What would be the price of the house? Do you see any pattern in the data? And according to that pattern, what would be the price of the house?
1100.
1100,
11.
right? So this is what, so many of you said that it is 1100. How did we get this 1100? We analyzed the data and we found some pattern in the data. The pattern that we found is that price is equivalent to 2 times the size of the house plus 100. So this is what the pattern that we found from the given data. So given a new house, I can make use of this pattern to make a prediction for these new instances. So given a new house for which I know the size of the house, I can just substitute it in this formula and I get 2 times 500 plus 100, which is equal to the 1100, isn't it? So that's how I've got this. So this formula, which is expressing the relation between the price and the size of the house, need not be explicitly coded. It can be automatically learned from the given data. Suppose if the data changes here, suppose if I give 350 here, 550 here, and 750 here, then the relation will change. Am I right? The relation will be 2 times the size of the house plus 150, right? So there is no point fixing them to certain values as in case of classic approaches. Am I right? Right. So the data is varying and the data is growing every day, every minute, right? So it means the model can be updated with the growing quantity of the data, right? It means the mission is improving with its experience, right? As the more and more data is more and more data is collected in the database, it means that you are adjusting this model according to the big data. I mean, with the growing quantity of the data, it means that model is improving as the data grows, as the experience improves, as you get the more experience, as the mission get the more experience. It means that mission is improving at the task, right? That's called mission learning. So, so machine learning algorithms model this relation with some unknown variables A, B, C. They will not fix them to certain values, unlike in case of classic approaches. And this A, B, C are determined through this data, available data. So whatever A, B, C is minimizing the difference between actual and the predicted ratings, that A, B, C will be chosen, right? That's the beauty of this machine learning algorithms. They have the ability to automatically learn from the given data. And that's the beauty of this machine learning algorithms. So I hope you understood the difference between the classic approaches as well as the machine learning approaches. So is that point clear? Shall we move on?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So why is this machine learning important? So as I have mentioned to you already, there is explosive growth of the data. We have already seen also this site, right? So data is the lifeblood of all the business because these data-driven decisions are increasingly making the difference, either keeping up with the competition or falling further behind. So here the machine learning is acting like a key to unlock the value of this data available, the corporate and the customer data available, and they enact the decisions that keep a company ahead of the competition. So not only in the business decision making, it has got lots of applications in other domains as well, including manufacturing, retail, healthcare, life sciences, travel, hospitality, automobiles, whatnot. You just show me one domain that doesn't have this machine learning application. It's very difficult to find out a domain that doesn't have this machine learning applications, right? So lots of applications of machine learning. In addition to the lots of applications, obviously, when you have more number of applications, it means more number of opportunities. So plenty of jobs available with high paying salaries, right? So machine learning is one of the best career choices of 21st century. It has got plenty of job opportunities with high paying salaries, right? So machine learning is on its way to make the drastic change in the world of automation. And in addition to this, there is a wide scope of machine learning in India. So these are all the reasons that why one should have to be thorough with this machine learning concepts in the today's world. All right. And depending on the kind of data exploitable, depending on the kind of problem that we are solving, we have different paradigms of the machine learning. So broadly, they are classified into three types: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning, unsupervised learning, and reinforcement learning. What's the time? 6:40. Okay. Please give me a second. Yeah, supervised learning, unsupervised learning, and reinforcement learning. In the supervised learning, we work with the labeled data. Data is labeled. We'll see what we mean by labeled data. So in supervised learning, we have got two problems: regression and classification. We're going to focus on both of these problems. In unsupervised learning, we have clustering and dimensionality reduction. We're going to cover these two techniques as well. In addition to that, we also have the association rule mining that we're not going to cover in this course, uh, as most of you might have covered it in data mining course if you have ever gone through it. Reinforcement learning, okay, which is also another learning paradigm. So various applications of supervised learning include medical diagnosis, farm filtering, weather forecasting, image classification, fraud detection, and so forth. And applications of unsupervised learning include image color compression, some meaningful compression, structure discovery, targeted marketing. All these are the applications of the unsupervised learning, but not limited to the ones that are mentioned in the slide. And reinforcement learning has got exciting applications including robot navigation, self-driving cabs, some skill acquisition, games. All these are the varieties of applications of the reinforcement learning. So we'll start with the supervised learning, then we will explore each one of them one by one. Okay. So as I have mentioned to you already, supervised learning, the data is labeled. Data is labeled in the sense for each object, there is a one label associated with that object, which is we are also calling it as a ground truth or the target variable. Okay. So here the label is acting like a supervisor to guide the learning process. It means what is correct, what is not correct to indicate that there is a label. That is why this label is acting like a supervisor to guide the learning process, and that's why it is called supervised learning. So we'll see what do we mean by the data is labeled. Okay, so here the data is labeled. You see that each image, there is a label associated with the image, indicating the gender of the image. Like for example, here the image is male, female, images of male, male, female, male, male, female. Right. So these are the labels. So for each and every object or the image, we have the corresponding label. Right. So given a new image, what is the corresponding label? This is what the supervised learning problem is. So we have given the objects and the corresponding labels for n objects and given a new object for which we don't know what is the label, and the task is to predict that label. Right. So this is what the supervised learning problem is precisely. So for any domain of interest, one can extract the features. Like for example, here we can extract features from the image, like what is the height of the person, what is the waist length of the person, leg length, eye width, hair length, eyebrow width. All these are the different features that one can extract to represent the image in the numerical representation that the computer can easily understand, right? So to simplify the problem, let us just take only two features, height and the waist length. So it means each image can be represented with these two features, height and the waist length, right? So now this data is converted to the numerical format. So these are the features that describing the image, and this is the corresponding target value indicating the label of the image, right? Indicating the gender of a person. So the height and waist length, we call them as the input variables or the features, Gender, we call it as the output variable or the label or the target variable. Okay, so we have given this input variables and the output variable, input variables and the output variable for few images, and given a new image for which we know the input variables or the input features, but we don't know what is the corresponding target value, and the task is to predict that. So this is what precisely the supervised learning problem is. So if I generalize it, the data looks something like this. We have given x1, y1, x2, y2, so on xm, ym, where xi is the d-dimensional feature vector, where xi is the d-dimensional feature vector indicating the features or the characteristics of the given object, and yi is the corresponding target value. Yi is the corresponding target value. Given a new instance for which we only know the characteristics of this object or the instance, we don't know what is the corresponding target value or the label. And the task is to predict this. So this is what is the supervised learning problem. Okay, so have you understood, all of you, what is supervised learning problem? Is that clear?
Yes, sir.
Yes, sir.
Yes.
Sir.
So now I said there are two problems in the supervised learning. One is classification, the other one is the regression. So what is the difference between them? Both of them are supervised learning problems. Both of them are in this format only. We have given x1, y1, x2, y2, so on, xm, yn, and given a new instance for which we only know the feature vector, and the task is to predict the corresponding target value. So what is the difference between the classification and the regression? The only difference between them is the type of the target variable. If the type of the target variable is discrete, we call the problem as a classification problem. If the type of the target variable is continuous, we call the problem as a regression problem. Okay, so if the type of the target variable is discrete, we call the problem as the classification problem. If the type of the target variable is continuous, we call the problem as a regression problem. So what do we mean by the discrete random variable, and what do we mean by the continuous random variable? Discrete random variable means it takes the finite and countable number of values. Like you see that there are only two possible values, female and male here. Similarly, whether an email is a spam or not, or to which folder an email should belong to, right? So all these are the discrete variables, right? Finite and countable number of values. Okay, or you can take an example of the dice. Dice, six-face die. What are the possible outcomes when you throw a six-face die? Dice. What are the
Six
possible?
options. Six.
One or two or three or four or five or six. Is it possible to get 1.5 or 2.3?
No.
Right, right. So if you take any two continuous values, it's not possible to get another value which is in between them. Then we call that variable as a discrete variable, right? If you take any two continuous values, if it is not possible to get another value which is in between them, we call them as a discrete variables, right? So if the target variable that you are interested to predict is a discrete, we call the problem as a classification problem. Okay. If it is continuous, continuous means it can take any value. Continuous means it can take any value. Like for example, weight of a person. Let's say the target variable is weight prediction, not the gender prediction, right? And the label that we have given also the weights on, right? 68, 72, like this, right? For this height and waist length, this is the weight prediction, right? Given a new instance, what would be the weight of this person? So weight is an example of the continuous variable, because weight can be anything, right? It can be 68, it can be 68.1, it can be 68.2, it can be 72.99, it can be 80.11, it can be 99.134. It can take any value. You can't restrict them to be certain values. Like you see that here we have 68, 72. Is it possible to have another weight which is in between them? Obviously possible, right? You can have 68.123, you can have 68.4, you can have 68.9, you can have 70, you can have 70.2. Many possibilities are there. So this is an example of the continuous random variable. And if the target variable that we are interested to predict, if it is a continuous variable, we call the problem as a regression problem. So have you understood the difference between the classification and the regression problems?
Yes.
So given some problems, will you be able to guess whether it is a classification problem or regression problem?
Yes, sir.
Yes.
Yeah, so let us try that. So email spam and non-spam filtering. Is it a classification or regression?
Classification.
Classification. Good. House price prediction.
Regression.
Regression.
Great. Detection of the news article type. Whether it is political news, cinema news, classification, right? Marks prediction.
Regression.
Regression.
Grade prediction. Grade prediction.
Classification.
Regression.
Classification.
Grade can be classification, right? Only few grades are available, A, B, C, D, like that. Yeah. This is classification. Weather forecasting, whether it is a sunny day or a rainy day.
Classification, sir.
Classification, right? Weather forecasting is a classification. Whether it is a sunny day or a rainy day or a cloudy
sir.
day, prediction of that is a classification. Temperature forecasting.
Regression.
Regression.
What would be the temperature tomorrow? That is a regression. Temperature is a continuous value. Very good. So now that you have understood the difference between the classification and regression, we'll be discussing them in detail in the coming sections. Okay. So we'll be proceeding to the unsupervised learning now. Yeah, here is the some video indicating the what is this supervised learning, right? So here you see that the machine is learning something from the images of the cats versus the non-cat, right? So this the data that we have given here is the some of the cat images, some of the non-cat images. So the machine is learning something and given a new image, as you see this side, as you see this side, right? Given a new image, it should be able to classify whether it is a cat or a not cat, right? This is a supervised learning problem because we have given the label of the cat versus the non-cat. We are training the machine and learning the model, and given a new image, we should be able to say what is a cat, what is a not cat, right? This is an example of the supervised learning. Okay, and the next one is the unsupervised learning. So in the unsupervised learning, we work with the unlabeled data. So the data is not labeled. We only given the feature vector, right? So if the only feature vectors are given, what can we make out of this data? Because we don't have any target variables or the prediction of them, nothing like that. We just given the feature vectors. Nothing else is given to us. So what can we make out of this data? Here, we try to find out the questions, answer to the questions like, are there groups among the data? Or is it possible to simplify the data, right? So if you're trying to find out the groups among the data, we call that as a clustering. If you're trying to simplify the data, we call that as a dimensionality reduction. So lots of applications of this clustering as well as the dimensionality reduction. Like for example, if you can group the customers based on the characteristics of the customers. So one can develop a business strategy group wise to improve the sales, right? To improve the sales, one can develop a business strategy because you're making the similar users as one group. For all this group, one business strategy. For another group, there is another business strategy. Like that, one can develop and make the recommendation accordingly, and that improves the sales. Not only in business, it has got lots of other applications as well that we're going to see as we proceed. Similarly, in dimensional reduction, we are trying to find out lower dimensional representation of the data without losing much information, right? So this will be helpful for the visualization as well as the simplification of the data. Okay, so these are the two unsupervised learning models that we're gonna discuss. So here you see that given the data, it is grouping them, all the circles into, all the balls into one group, all the cubes into one group, all the cones into another group, right? You can see that, right? So this is a kind of grouping, kind of clustering that it is doing. All right, so this is the kind of unsupervised learning. All right, so the next one is the reinforcement learning. The last paradigm that we're going to discuss is the reinforcement learning. In the reinforcement learning, the machine learning algorithm or the reinforcement learning algorithm, we also call it as an agent. Agent is receiving some inputs and taking some action, right? So agent we call is an agent, but it is actually reinforcement learning or the machine learning algorithm. Agent is interacting with some environment. Environment could be a gaming environment. Environment could be a driving environment where the robo is driving, or the self-driving cabs. Or environment could be a restaurant where the robo is serving some food for you. Environment could be some store where the robo is placing things at the right places, right? Nowadays, you might have seen this, right? The robots are serving in the restaurants. Robots are cleaning the home, right? So that I have seen recently, one of my friends sent this, that robo mop, right? That automatically goes everywhere and cleans the home, right? So like that, lots of applications that you see. So the agent or the reinforcement learning is interacting with some environment. Environment could be a home, environment could be a restaurant, environment could be a store, environment could be driving environment, or environment could be a gaming environment. It could be anything. But whatever it is, the environment has got some state. How do you define the state of the environment? Like, for example, you take the chess game where the robo is playing the chess game, computer based games, right? So how do you define the environment of the chess game? What defines the state of the environment? Depending on how the coins are placed on the board. Am I right? Where the king is placed, where the horse is placed, where the elephant is placed. All this defines the state of the environment, right? And based on the current state of the environment, the algorithm or the agent takes some action. Action means, like, for example, move this horse from this place to this place, or move this elephant from this place to this place, right? So like this, you're taking some step, that we are calling it as the action. Agent is taking action. You see that agent is taking action. As a result, what is happening? As a result, state of the environment is changing. State of the environment is changing. Also, agent is receiving some reward for that. What kind of reward? If the action taken by the agent is leading to win the game, he may receive some positive reward. Is leading to lose the game, then he may receive some negative reward for that. And the goal of this agent is to maximize the reward. Okay. In simple words, it's like the way that you train your dogs, right? How do you train your dogs? Let's suppose you got a new dog. You want to train it. Right? Like, for example, you want to train it in such a way that whenever you throw a ball, you want the dog to get the ball back to you. This is what you want to train, right? What do? You emulate a situation by throwing a ball. Simply throw a ball. So that our dog may be taking some random actions initially, like it may be jumping, it may be sitting, it may be standing, it may be barking, it may be doing some random actions, right?
Excuse me, sir.
Yes.
Sir, who will be giving rewards to this agent? Does it itself
Rewards are
calculates the rewards?
defined explicitly. Like positive rewards or negative rewards are defined based on the action that the agent is taking, and the goal of the agent is to maximize the reward. Like, for example, I can give you an example. Like, you take the self-driving cabs. Self-driving cabs are what? Given some environment, driving environment, the cab should be able to pick up a person at one location and drop off the customer at another location. And this pickup and drop off locations are defined. Okay. So there are different possible actions for this cab to react, like move north, move east, move west, move south, right? 4 possible directions it can move anywhere. And also it can pick up the customer, it can drop off the customer. Suppose if the cab is picking up the customer at the wrong location, is it a desirable behavior or undesirable behavior?
Undesirable.
Undesirable. Wrong location pickup is undesirable and it is not at all acceptable. Then you may give some negative reward like -10. You can define a minus reward -10. So suppose if it is picking up the customer at the right location, is it desirable behavior or undesirable behavior?
Desirable.
Desirable. You can define some positive reward +20. Right pickup, right drop off +20. Wrong pickup, wrong drop off -10. Whether it is taking one step, you can define a reward of -1 because you want to minimize the overall number of steps, right? to pick up, I mean, to drop the customer at the right location, right? It shouldn't happen that it will be taking infinite number of steps, right? So some reward should be associated with each step also. Now,
Yes,
once you
sir, you
define
have
this,
given correct example, but I think the question was who places the reward or punishment.
that's
Yes,
what
Reward
I'm
is
yes.
saying.
given
The
by agent.
environment defines them.
Yeah, but
You-
who places it? Like agent or like
Agent nahi, the one who is defining the environment. It means you. I mean, if you are implementing it, you will be defining it.
It's like if he picks up the, how can he picks up when the person is not available at that moment in the wrong location? Then
yes, yes.
automatically, there is no point of picking up a person when he is not available in
Nahi,
the
nahi.
location.
See, that you know it, but the system doesn't know it, right? So agent is taking some random actions initially. Okay. So like the
Yes,
way the
yes.
dog is taking random actions, right? It may be reacting in multiple different ways. From all the possible actions, it is picking up one action initially, right? And whenever it picks up the right action, you are like, let us go back to this example itself. Like you're training the dog, I said, right? So you emulate a situation by throwing a ball. Please mute yourself if you're not speaking. It creates a disturbance to others. So emulate a situation by throwing a ball, right? Now, the dog may be reacting in multiple ways. Santosh Kumar sir, please mute yourself. Yeah. Emulate a situation by throwing a ball. Now, dog may be reacting in multiple different ways. It may be barking, it may be um, standing, jumping, whatever it is, right? So whenever it picks up the right action, you can offer him a snacks, right? Or whenever it picks up a wrong action, then you can punish him, right? So over a period of time, what will happen? The dog will learn to do the right things or desirable behavior. So when you throw a ball next time, it may get the ball back to you with even more enthusiasm of getting the snacks, right? So the same behavior, if you can simulate in a mission, that's called reinforcement learning, right? So you're giving the negative and the positive rewards to the agent based on the action that he is picking up at that moment, at that state, right? So, and the agent is programmed in such a way that it has to maximize the reward. Okay, so over a period of time, what will happen? That it will learn to do only desirable behavior at any given state. Okay, I hope you're following, madams.
Yes, so we can what we have understood is that the agent is the one who like places the reward or the punishment, right?
No, no, no. Agent is not placing the reward or punishment. The environment is giving him the reward or the punishment. Agent is only taking action by reading the current state of the environment.
Okay, okay, fine. Okay.
Yeah, so the agent is just taking action. You can see the diagram also. Once the agent takes an action, the state of the environment will change and also he receives some reward for that. And the goal of the agent is to maximize the reward. So over a period of time, it will learn to do or do the actions that are desirable at that state. Okay, so we'll be looking at one of the application of this in the hands-on session, that self-driving cabs. Then you will understand it better. We'll be discussing some algorithm also. Okay, but this is the idea behind it. I hope you got the idea. How we'll be seeing it later, how it does all that, we'll see later. But have you followed the idea of the reinforcement learning?
Yes, yes,
Yes.
yes, sir. Yes.
Yeah. So observe the environment, decide how to act using the strategy and act accordingly, and receiving the reward or the penalty, and learning from the experience and use this experience to refine the strategy. Okay, so this is iterated until the optimal strategy is found. Okay, so that's what the reinforcement learning is doing. Am I audible?
Yes,
Yes,
sir.
sir.
Yes. Okay. Yeah. Some voice I heard. That's why I'm doubtful. Okay. So these are some of the reference books. Some slides are repetitive. I'll remove them. These are some of the reference books. The first one is very much useful book, but slightly difficult to read for a beginner. Okay, so this is very good. All these are good books. Okay, but this is most of the topics that we're gonna cover is in this. Okay, and this also. Okay, fine. So that's all for today. The theory part. If you have any queries, I can take. You see this now. Now you see that it has been more than 40-50 minutes. Okay, 9,38,000 minutes of video have been uploaded to YouTube. Okay, I can't read this number also. I think it is 23 crores 8,15,000. Okay, so you see that the kind of data scroll. Fine. So if you have any query, I can take. Otherwise, we can move to this
Sir,
hands-on part.
may I talk?
Yes, please.
Okay, so what I have understood from today's session is that in conventional approach, the input is considered to be a data and a program, and output is considered as some label or something. But in machine learning approach, input will be a data and a label, and output will be a program, right?
Not exactly. In the traditional algorithms, in the conventional algorithms, they assume that this relation, which is expressing the relation between output and the input variables, is known to us and it is explicitly coded. Like the way you have seen, right? Price is equivalent to some 3.1 times of the size of the house, 0.7 times of the size of the garden, and so on, right? That formula is known to us and it is explicitly coded in case of conventional algorithms. Whereas in case of machine learning algorithms, from the given data itself, we'll be able to learn that relation. That's the advantage of the machine learning algorithm, is the beauty of the machine learning algorithm. They have the ability to automatically learn this pattern or the relation from the given data. So they model this relation with some unknown variables ABC and they determine them using the given data, whichever is suitable, right? Whichever values are suitable for this ABC, according to the given data, we choose them. Okay.
Hello, sir.
Yes. Ma'am, is that
Sir.
clear before we proceed to the next question?
Yes.
Sir,
Yeah.
could you share the PPT? Is it shareable, sir?
I've already shared that, sir. I've given you this drive link on the WhatsApp. In that, all the slides are available.
Okay, sir. Thank you, sir. Thank you. WhatsApp group, sir. Okay.
WhatsApp group.
Now it's over, sir.
No, not it. I am just waiting for any questions so that we can move to the hands-on part.
Let's go ahead, sir.
Okay. So I have shared this software installation instructions. Okay. So I hope you have installed, and I hope that many of you already know Python. If no, also it's okay, right? Because I'll be starting from the very basics. Okay. Because I assume that you know nothing. Okay. I mean, in terms of the machine learning and the Python. So that's what the assumption that I've made when designing the course. So we'll be starting from very basics. Okay. So I've already shared this how to install the Jupyter notebook. If you install it, it's okay. Otherwise also it's fine. I'll tell you how to do it in Google Colab. But if you have installed it, okay, how to open it? Go to the search bar, type Jupyter. Okay, so you'll get the Jupyter notebook Anaconda 3. Click on it. One window like this will be opened and one tab will be opened in your browser. Okay, so it is a bit slow, but bear with me. Yeah, so one tab like this will be opened in your browser, right? So go to the appropriate folder. Like say, let's say I just going to this, let's say. Go to the appropriate folder where you want to create Python for ML. I'm going. So if you want to open a new notebook, click on this new new tab that you have here. Click on Python 3. Click on Python 3. So one separate tab will be opened like this. So in that you will have this, right? Jupyter Notebook. So give appropriate name. Okay, I'm just renaming it. You can directly also rename it. Rename. Okay, Python basics. Okay, August. I'm just renaming it. All right. So once you rename it, okay, so you can start writing your code here. If you want to give some annotations or some headings or some description about what you're going to write, you can change the cell type. So go to the menu. In the menu, click on cell. After that, click on the cell type and click on markdown, right? So I'm just marking down something. I'm just giving some heading here, Python basics. Okay. So in today's session, we're going to cover data types, and data structures. Okay, so this is what we're going to cover in today's session. Day 1. Okay, so like this, you can give some heading, some meaningful heading, some meaningful description about the data. Now you can start writing. To execute any cell, you just have to press Shift Enter. Shift plus Enter together. Shift plus Enter together. Okay. So you can also try. I'll show you if you have not installed Jupyter Notebook. I'll show you the other way. Please hold on for a minute. Okay. So you can start writing whatever the code that you want to write on the cells, coding cells. By default, it is a code cell only. If you want to make it as a text cell, you can go to the cell type and click on the markdown. Okay. So like for example here, I can just define C equal to A plus B program or hello world program. So print hello world. Okay. So I'm just calling print hello world. Okay. To execute this, I'm just pressing Shift Enter. Hello world. Okay. Fine. So like this, you can execute. So how to execute, I've just shown. So if you have not installed Jupyter Notebook in your system, don't worry about it. Okay. So let me show you the alternative way. You can do the same thing in Google Colab. Okay. So to open that, just go to the search bar, just type Google Colab. Google Colab. So once you click on that, once you type it, click on the very first link that you get. Okay, so after clicking on it, something like this will be opened, right? You can click on side by. If you want to open the existing one, you can open it. But if you just want to create new one, you just click on side by here and go to the file, click on the new notebook. Go to the file, click on the new notebook. So one window like this will be opened. Okay, it is slow actually. That's why I'm more comfortable working on the Jupyter Notebook. So I'll be doing it in Jupyter Notebook only, but if you want to do it in Google Colab, you can do it. So whatever that I'm writing in Jupyter Notebook will work here also. So you can do that. Okay, whatever that I am doing in the Jupyter Notebook, you can do it in Google Colab. So you can give some appropriate name here, like Python basics or whatever. Okay. Appropriate name for this, and then start writing your code. So here, if you want to create a markdown cell, click on plus text symbol here. So if you want to create a coding cell, you can click on plus code. Okay. Like for example, here I can create a heading called Python basics day 1. Okay, same thing, whatever that I have written, you can write here. Data types and data structures. Shift enter here also. So you see that. Okay, so you can write here also the same, print hello world. Same thing. Shift enter. Control enter also works, but control enter will be in the same cell. It will not proceed to the next cell. Okay. So shift enter, it will execute and it will automatically go to the next cell. Okay. Cell level it is printing, right? So like this you can execute. Okay. So I'm just leaving this. Understood, right? How to execute a program. Okay. So
Yes,
I'm going
sir.
to the Jupyter.
Sir,
Yes.
sir, I'm surprised though their use of GPUs just to print a hello world, it is taking minimum some 10 seconds.
Yeah, that is the problem with the internet. Even that is slow in my system also. What happened to this? That's why I'm doing it in local Jupyter notebook. Fine. So clear. Shall we proceed?
Yes, sir.
Yes.
So we'll start with the. Give me a second. We start with the data types.
Sorry, sir. Sir, I want to interrupt.
Please.
Hello, sir.
Yes. Go ahead.
Sir, please start once again in the Jupyter. How to start the Jupyter in your if you already install in your system?
Go
From
to the
beginning,
search
sir.
bar. Type Jupyter. Search Windows S. You can press Windows plus S.
Yeah.
Type Jupyter. You will get this Jupyter notebook. Click on it. One tab will be opened in your browser like this.
Okay.
It will be open. You can start doing that.
Okay. Thank you, sir.
Yeah. So unlike in case of the other programming languages, the C, C++, Java that we see, we need not declare variable in case of Python. You can directly use them. Okay, and type of it will be taken automatically, right? It's like, for example, if I take a variable A and assign a value 5, you can see the type of it. It will be automatically taken as an integer type. Okay, so I'm just printing A and type of it also, type of A. You can see that it is taken it as an integer. Similarly, you can take the floating point values, like let me take some 5.4. I can do the same thing here as well. So I'm just printing B and type of it. So it will be automatically taken as a floating point. Okay. Similarly, the Python also supports the Boolean type, complex type, string type variables. Okay. So here I'm taking another one, some complex variable, some 4 plus 5j, something like this. You can print C and type of C. This is of complex type. And you can take another variable D, which is of some Boolean type, true or false. Okay. Can print D and type of it as well. And you can take another variable E, let's say, and take some string type, string variable, hello. Okay. You can print E and type of it also. See that complex type, Boolean type, string type, they're automatically taken, right? So I'm just copy pasting this to you on the chat box. This file will be shared with you. It's already there in the in your drive. Okay, so you can access to that later. Okay, so so like this, you can use any variable and assign some value, and the type of it will be taken automatically. Okay. So we're going to see the 4 important data structure that Python supports. Okay, so 4 of them are lists, dictionaries, list tuples, sets, and dictionaries. These are the 4 data structures that we're going to see the Python supports. Okay, so we'll start with list. So any of the data structure, what we are interested in, how to create a data structure, how to access the element from the data structure, how to insert the elements into the data structure, how to update the elements into the data structure, or how to delete the elements from the data structure, isn't it? how to insert, how to access, how to update, how to remove, right? So these are the things that we are interested in any data structure, right? So we'll start with how to create this list, and then we will see how to access it, access the elements, and how to insert the elements or update the elements. Also, we'll see how to remove the elements from the data structure, right? So we start with how to create a list. So this data structure is created by using the square brackets. Square brackets, if you just give this, it will create an empty list. I can show you that. Print type of L1. Okay, so it will be automatically taken as a list, right? So if you want to pass some elements, it's kind of array that you are creating, array of elements, list of elements, right? So I'm just creating an list of 5 elements, 1 2 3 4 5, right? So it is an ordered list of elements, right? And here you see that when I print L1, it will be taken it as a 1 2 3 4 5 list of elements. It will be printed. This is one way that you can create a list. The other way is by calling a list function. So you can call a list function and pass a set of elements or a tuple of elements to it. It will automatically create this list. Okay. So this is a way to convert a tuple to list also. Okay. Translation also, creation also possible through this way, right? So I can print L2 and a type of it here also. It will be the same as this. Both of the ways are same. I mean, both the ways create a list of this 1 2 3 4 5, right? So we have seen how to create a list. Now how to access the elements from the list. How do you access the elements from an array? Using indexing, am I right? And indexing starts from 0, right? 0, right? So suppose if I want to access 1, what should I give as index number? 0. L1 of 0, it will access 1. If I give L1 of 3, then it will access 4, right? So like this, you can access the elements of this, individual elements of the list. Python also supports accessing slice of elements at a time. Okay, so accessing slice of elements at a time. Suppose if I want to access 2 3 4 at a time, slice of elements at a time, Python have support for that also, accessing slice of elements. So I'm just printing L1 again for our reference. So this is 1 2 3 4 5. Now if I want to access the 2 3 4 slice, one slice of elements, 2 3 4, right? So you can access, I'm just printing that directly. You can access L1 of starting index. What is the starting index? If I want to start from 2,
1.
start 1, right?
1 1.
1 is to end index plus 1, end index plus 1, right? So specify end index plus 1. So what is the end index?
5.
3, right? End index is 3 plus 1 means 4.
4.
So you specify 4 here. So A is to B, kind of. A is the starting index. A is the starting index. And B is the end index plus 1. Okay. So now I'm executing this. You see that this is accessing 2, 3, 4. So now can you tell me how can I access 1, 2, 3? What should I specify to access 1, 2, 3?
0 colon 3.
0
0 to 2. 0 colon 2.
0
3.
colon 3.
0 colon 3,
3,
right?
3,
Plus
3,
1.
3.
3
If
3.
3 plus 1. 0. Sorry, 0 colon 3. Okay. So this is equivalent to specifying nothing here. So suppose if I don't give anything here also, by default, it will take it as a 0 only. Okay. So this is equivalent to that. Okay. You see that. So if you don't specify anything here also, it will take it as the same. How can I access 3, 4, 5? 3, 4, 5. What is the starting index?
2.
2 2
2
2.
and
5.
5. 5.
5, right? So 2, 3, 3, 4, 5 it is. Now, if you don't specify anything here also at the second place, then by default it will take it as the end one, right? So it will proceed till the end. So 2 is to nothing. If you give here, then it will take till the end. Okay, so you see it is equivalent to that. Suppose if you don't specify anything at both the places, at the location of A, at the location of B also, can you guess what it will access?
All elements.
All the elements. Yes. 1, 2, 3, 4, 5. So you have an option to access the alternative elements or the stepwise also. I'll show you that. Suppose if I'm starting at the 0th location, or you can specify nothing also there, it's equivalent to that, ending at 4 plus 1, which is 5, and with a step size of 2. It means you're accessing the alternative elements starting from 0 index and index plus 1, which is 5, and alternative elements you're accessing. It means after accessing the first element, you'll be accessing the third element, then fifth element, and so forth, like that. So now this will access 1, 3, 5. You see that. Okay. Suppose if I give the step size as 3 here, then
1,
Yes.
4. 1,
1
4.
and 4, right? 1 and 4. Suppose if I don't give anything here, is to 3, then it will be same as this, right?
Same.
1 and 4, right? Yeah. So like this, you can even access the alternative elements also. Like this is how you can access the slice of the elements. And Python also supports the reverse indexing. Suppose if you give the negative elements in the programming languages like C, C++ or Java, it will throw an error. If you give the negative elements, if you pass the negative elements in the index, but here it is not like that, right? So if you pass the negative elements, it will be taking it as the reverse indexing, right? So give me a second. Reverse indexing. Okay, so in the reverse indexing, -1 indicates the last index. Okay, -2 indicates last but one, and so forth. So if I want to access the last element, I can give -1 as the index. So you see that 5 is accessed. So if I give -2, then what do you think it will print?
4.
4 it will print. -3, it will print 3,
3.
right? And this slicing also can be done in the reverse indexing as well. Suppose if I give -4 is to -1, okay, or 0. Okay, that means you're starting at -1 and ending at 0 plus 1. 0 plus 1. Okay. I'll not give anything. Okay. Let me take -1. Okay. You see that. Now it is giving 2, 3, 4. All right. So like this, yeah, like this, it will be you can do this slicing in the reverse indexing as well. You can do it in the reverse order as well. Like for example, if you start at 5 and go till 2, right? So you can start at 5, it is -1 indexing, and 2 means till -4, -4, you want to go with a step size of -1. Okay, so 5, 4, 3. So if you give -5 here, then it will go till 2 also. 5, 4, 3, 2, like this, right? So you can go in the reverse order as well, like this. Okay, so the slicing also can be done in the reverse order. Fine. So far we have seen how to create a list, how to access the element, how to access a single element, how to access the multiple elements, and how to access them in the reverse order using the reverse indexing. All right. So this is what we have seen. So we can also create the nested list also. Nested list. We'll see how to create a nested list. Nested list. So to create a nested list, let's say nested list L3. So you can create a list of list, right? So you can take the outer list and inner list also. Inner list 1, 2, one list 1, 2, 3. Let's say another list is 4, 5, 6. It's like a 2-dimensional array, right? So now how to access this? Let me just print this. So how to access this? Suppose if I give L3 of 0, what do you think it will print? What is the first element of the outer list? Isn't it the first element? 1, 2, 3. The first inner list, isn't it?
Yes.
Hello? Right. And if I give L3 of 1, then what do you think it will print?
4, 5, 6.
4, 5, 6. Right. So how to access this now? Open another bracket and open 0. Put 0. Right. It means within this list you are accessing the 0th element. So what do you think it will print?
4.
4. Right. So like this you can access the nested list. Okay. You can even do the slicing and all in the nested list as well. Okay. What else? Python also supports the heterogeneous list. I mean, the list need not be of the same type all the time. So you can have a list of the heterogeneous data elements. Like for example, I can have a list of integer, one element as integer, another element as a floating point, another element as a boolean, another element as some complex number, another element as another list. Okay, so Python supports all this, right? You can give any of this, another element you can give string, some string. Okay, so you can have a list of the heterogeneous elements as well. Okay, so you can see that this is of type list, and the accessing is also same way that you access the normal list. So far we have seen how to create list and how to access them. What is the other operation that we are interested to perform on the list or any data structure for that matter? How to insert the new elements into the data structure, right? So how to append the elements to this data structure, right? That is another operation that we are interested to perform, right? So how to append the elements, how to add the elements to this existing list. Okay, let us see that. Okay, so let's create a list. L1 is 1, 2, 3, 4. Okay, I'm just recreating it. Now I just want to append a new element 6 to this. How to do that? Okay, so if you want to append a new element, let us do it. L1 dot append. There's a function called append. You pass the element that you want to append here, 6. Element that you want to append, which is 6. Okay, so I'm just printing now, printing L1. Okay, so now you see the printer. 1, 2, 3, 4, 5, 6. So this is how you can insert the element at the end of the list. Suppose if I want to append list of elements, not just one element. Okay, I just want to append 6, 7, 8, 3 elements at a time. Is it okay if I pass the list of elements 6, 7, 8? Okay, let me just print what it gives. You see that this is what it is giving. But is this what we expect? How we want it? We want the individual elements of this list to be added to the L1. Am I right? Not as a list. Hello? Am I right?
Yes.
Yes, sir.
Not like this, right? We want to add the individual elements of this list 6, 7, 8 to this existing list L1, right? So, but this is adding it like one element in the existing list, right? This is not what we expect, right? So to do that, what we do is that instead of calling this append, we call this extend function. Okay, so let me call it here. So the same thing I'm repeating. Instead of append, I'm calling extend this time, right? Now you see that. Now the individual elements of the 6, 7, 8 are added to this existing list, right? So if you want to append a list of element, call the extend function, not this append function. Okay, fine. So now we have seen how to insert the elements at the end, right? How to append the elements to the list at the end. What if you want to insert the elements at a particular location, in the middle of the list or at the beginning of the list, at the location that you specify, right? So we can do that also. We can insert the elements at a specified location by calling the insert function. So I'm calling the insert function. Suppose if you want to insert some at second location, index number 2, you want to insert 0. Okay, so you will be inserting 0 at this location, and whatever the element that are present at that location will be shifted to the right. Okay, so earlier 3 is present at that location. Starting from 3, all the right side elements will be shifted to one position right, as you see here. Okay, so this is how you can insert the element at a particular location. So what if you want to insert a slice of elements at a particular location? Like the same index 2, starting from index 2, I want to insert 3 zeros, not just 1 0, right? So how do you do that? Okay, so to do this, what we do is that you call this L1 of index where you want to insert. Okay, 2, right? 2 is to 2 you mention, and specify the list of elements that you want to insert. How many ever, right? 3 zeros I want to insert. So whatever the values that are present at those locations will be shifted to the right. 3 zeros are inserted at starting from this second location. This is how you can insert this slice of elements at a location specified. So we have also seen how to insert.
So I did not get this 2:2 from the location to.
And location, if you specify 2:2, madam, it is inserting this slice of elements starting from that location that you specified. If you give the starting and ending index as the same.
Okay, sir.
Suppose we have seen how to insert at the end, how to insert at any location. We have seen how to insert a single element, how to insert a slice of elements as well. All right, so now we're going to see how to update the list. How to update them means, update means what? Modifying the existing elements, right? So how to update the list, right? So suppose there is a list here, L1 equal to 1 2 3 4 5. Instead of 2, I want to make it as a 0. 2, I want to make it as a 0. How do you do that? L1 of, what is the 2 index number? Index number of 2, element 2?
3.
1, right? 1, oh, sorry. 1, right? Index, sir, I think you're confused.
1 1.
A 1, right? Yeah.
L1
So I
1.
want to make it 0, right? So L1 of 1 equal to 0. You make it, it will be updated to 0. Now you see that it is updated to 0. So what if you want to update a slice of elements? Okay, not just one element. If you want to update a slice of elements, how to do that? Slice of elements. So like I want to update 2 3 4. Okay, so 2 3 4. What are the index numbers? 2 3 4. I'm starting at index 1 and
5. 2 to 5.
2 to 5 or 4?
0 1 2 3 4.
4, right? So ending index is 3. 3 plus 1, 4. Right? So I want to give 3 zeros, right? You can specify the list of 3 zeros. 0 0 0. Right? So let's see whether this will work. Yeah, this is working. 1 0 0 5. This is how you can update the slice of elements. Here you see that whatever the index numbers range that you specified is equivalent to the number of elements that you are passing here. Index range that you specified is 3 and elements also you are passing 3. What if it is more than or less than the index range that you specified? Suppose I specify the index range as a two values and pass the 3 numbers here. What happens? So let's say I just gave 1:3 here. 1:3 means how many locations? 1 and 2. Only 2 locations, right? Corresponding to 2 and 3. Am I right? Hello?
Yes.
Yeah. So now I am specifying 2 index numbers here, but giving 3 numbers here, right? But this slice that you have specified will be replaced with these 3 zeros. Okay. So it will not throw an error. It will be replaced with this 2 3. So 2 3 will be replaced with triple zeros. Whatever the existing values at those locations will be shifted to the right. See that. 0 0 4 5. So 2 3 slice is replaced with 4 5. What if it is less than this number of elements? Number of elements specified is lesser than the range specified. What happens? Suppose if I give 1:4 here, how many locations I am referring to? 1:4 means 3 locations, right?
3 locations.
Suppose I just gave 1 0 here, not multiple zeros. Then the slice will be replaced with a single 0. It means you will get 105 as the output. 105 as the output. So like that, you can specify any slice and update that slice with whatever that you specify on the right hand side. Okay, so this is how you can update the elements. So we have seen how to access, how to create list, how to access it, both forward and reverse indexing and slicing as well. Then we have seen how to insert the elements at the end at the any location specified, and then we have seen how to update the list. Okay, the next one is what? Insertion is done, accessing is done, updation is also done. What else we left with? Any other operation that you want to do? Anyone?
Deletion.
Deleting or removing the elements from the list, right? Removing the elements from the list. Okay, so let us just redefine it. L1 equal to 1, 2, 3, 4, 5. Suppose if I want to remove an element, you can call L1.pop. L1.pop, if you call, it will remove the last element from the list. After this, you can print L1. You see that it is only having these 4 elements, 1, 2, 3, 4. So this, if you print this L1.pop, whatever that it returns, it will print. So it is returning the popped up element. It means 5, it will print, right? So this is the element that is popped off, and the remaining list is 1, 2, 3, 4, right? So you can even specify the index number to remove a particular element also. Suppose if I call L1.pop of 2, it means the element that is present at index 2 will be removed, right? So what is the element that is present at index 2?
3.
3. 3 will be removed. The remaining list will be 1 to 4, right? So 3 is removed. This is what it is returning, 2, 3 and 1 to 4 remaining list. Okay. I think you can specify the value of the element also and remove it. I don't remember. Let me try this. L1 dot remove. Remove, I think, if I remember correctly. Let's say 1. Okay. So this is, let us, if it works, I will explain. Yeah, it is working. So L1 dot remove of 1. It is removing an element 1, not the element present at index 1, right? So it means with the element number also, with the element name also, you can remove the element by specifying the remove. It returns none and remaining elements L1. Okay, 2, 4. Okay, like this you can remove. Okay, so this is removing a single element by specifying the index or the element itself. Okay, if you want to specify remove the end element, just call the pop. If you want to remove the element present at a particular index, specify pop of index number. If you want to remove a particular element, call L1.remove of that element. Okay, so now how to remove a slice of elements? Okay, how to remove a slice of elements? So let us just again take this L1 equal to some 1, 2, 3, 4, 5. Okay, so I want to remove 2, 3, 4. Can you use the existing knowledge? I mean, the knowledge that you have acquired so far in this session, and tell me how to remove a slice of elements. I just want to update this 2, 3, 4 with an empty slice.
Empty slice.
Right. So it means what? L1 of 2, 3, 4 means starting at index 1, ending at index 4. Can I replace it with an empty list? Will this work? It should work, right? Hello?
Yes, sir.
Yeah, so you see that after this, I've just got 1, 5, right? So it means that slice is replaced with an empty list, nothing, right? So 1, 5. There is another way of doing the same. Another way of doing the same, okay, using the delete keyword, del keyword, del keyword. Del, delete, L1 of, specify the range. L1 of 1 is to 4, right? So now you can print L1 again. It's the same, right? Fine. So these are the two ways that you can remove the slice of the elements. Suppose if you want to remove the whole, clear all the elements, you want to make the list empty, right? You can call L1.clear. L1.clear, then you can print the L1 again here. Okay, so it's an empty list. It will clear all the elements, but it keeps the list. Okay, suppose if you want to remove that as well, then call delete of L1. Don't specify any range. Okay, Now, if you try to print this, it will throw an error because this list doesn't exist. See that L1 name is not defined. Okay, so I'm just commenting that out. All right. So this is how you can remove the elements or clear the elements, or I mean a single element or multiple elements or the whole elements or the list itself. Okay. So done, right? All the 4 operations: how to create, how to insert, how to access, how to update, how to remove, right? So what else we need in a data structure? Some built-in functions that this supports, right? So Python built-in functions for this list. So let us see some of the built-in functions that Python supports in the context of list. Okay, so I'm just taking the again 1, 2, 3, 4, 5. Okay, so like if you call L1.reverse, it will reverse the elements of this list. Now you can print L1. You see that it is the elements are reversed 5, 4, 3, 2, 1, right? So like this, there are various other operations that the list supports. The other built-in functions like count also there. Let us take some duplicate elements and count the number of occurrences of the element. So I'm just inserting some random 1, 2. Okay, so how many ones are there in this list? How many ones are there?
4.
4, right? Suppose if I call L1 dot count of 1, right? So it will return a 4, right? So number of occurrences of 1, right? Number of count of 1, right? How many times it is repeated. Similarly, you can sort this L1 by calling L1 dot sort. Okay, L1 dot sort I'm calling. I'm just printing L1 now. Okay, now you see that the elements of it are sorted, right? So now if you want to sort them in the reverse order, you can just set the reverse equal to true. Oh God. Reverse equal to true. By default, reverse is false. Now you see that it is sorting them in the reverse order, right? So like this, you can apply various functions on the various built-in functions on the list. And there are some generalized functions also, like if you want to find out the maximum element of L1 or a minimum element of it, you can do that by calling max and min. Okay, and you can even get the length of L1, which means the number of elements in it. Okay, 11, right? So like this, you can use these functions to acquire the different information that you require from this list. Okay. Another one more important thing that I would like to demonstrate is how to copy the list. How to copy the list. So is it okay if I just want to copy L1? Let's take L1 equal to 7. Okay, I'm just taking, it is convenient to type. That's why I'm taking the integers 1, 2, 3, 4, 5. You can take anything. So is it okay if I give L2 equal to L1? Will this work? Let us see.
Yes.
Print L1. I'm just giving some slash n. L2. Both the things I'm printing. So both of them are same, right? It means it's working, right? But there is one problem with this. Problem with this is that whatever the changes that you make to L2 will also be reflected in L1. Suppose I'm just making L2 of 1 equal to 0, right? I'm just again printing them. Okay, so I'm printing it again. Okay, now you see that whatever the change that you're making to L2 is also reflected in L1, isn't it? Hello?
Sir.
Have you noticed it?
Yes,
So it
sir.
means what? It is copying it by reference. But most of the times you don't want it this way, isn't it? You just want to copy it, right? And make some changes. You don't want these changes to be reflected in the original list as well, right? So what you have to do if you don't want this, right? There are two ways that you can do copy the values only. One is that instead of giving L1 here, you just give L1.copy. L1.copy. Now you see that whatever the changes that you're making to L2 is only in L2, not in L1, right? Have you noticed it now? The difference between the previous one and this one?
Yes, sir.
Yeah. So another way is that you can just copy the elements by calling L1 of column, right? So starting from the starting index to the end index, you're just copying the element. This will not also not make any changes to the original list. Okay. All right. So if you want to combine the two lists, okay, you can have a plus symbol L1 plus L2, which combines both the list 1, 2, 3, 4, 5, 1, 0, 3, 4, 5. All right. So these are the various things that I wanted to demonstrate. Some more things we'll see as we proceed. So we have seen how to create a list, how to access the elements from the list, both forward and reverse indexing, slicing operations as well. Then we have seen how to insert the elements, insertion at the end, insertion at the specified location, insertion of the slice of elements, insertion of a single element. Then we have seen how to update the elements, update a single element, update the slice of elements. We have also seen how to remove the elements, removing a single element, removing a slice of elements. Then we have seen some built-in functions and how to copy the list. Okay, so these are the various things, important things that we have covered from the list. The same things we'll also see from the other data structure, tuples. Okay, tuples are same as the list. Only difference is that tuples are immutable. Immutable means they're not changeable. Once we define them, you cannot change it. Okay, set lots of places like you don't want to change or make, don't want the application to, or don't want to allow the application to make any changes to some certain data structures in some of the applications. So in those applications, tuples are very much helpful. Okay. So not only that it provides that advantage, it has another advantage also, because they are not immutable. You can allocate the space of the space at the continuous locations. So the elements of the tuple can be placed in the continuous locations in the memory. Once they are placed in the continuous locations in the memory, it is easy to access them through the locality of reference. So therefore, tuples are much faster as compared to the list because they are placed in the continuous locations in the memory. So using the concept of the locality of reference, you can access them faster as compared to the list. Whereas in case of list, because they are frequently changing, you cannot define them to be in the continuous locations, right? So it takes them more time as compared to the tuples to access the list. Okay, so to define a list, we have used the square brackets, right? To define a tuple, we use the parenthesis, right? So T1 of some empty parenthesis, if I give, it will take it as a tuple. I hope you're following, right?
Yes, sir.
Sir.
Yeah.
Yes, sir.
Thank you. So you can give a list tuple of elements here also 1, 2, 3, 4, 5, and this is the type of it. Okay, there is another way of doing it by using the tuple function. Also, you can do this. T2 equal to some tuple of, you can specify the list of elements. This is the way to convert a list to the tuple as well. Okay, so the same thing you can give it here also. Okay, so I'm just giving T2 comma type of T2. Both of them are same, right? So this is the way, this is how we can create a tuple. Now what next? How to access the elements from the tuple? Accessing is same as the list. I mean, single element, reverse indexing, slice of elements, everything is same as in case of list. So I need not demonstrate them, right? So, but updation, tuple doesn't support the updation. Like for example, if I want to update T1 of 0 to 0, okay, some change I want to make, it will throw an error. You see that tuple object does not support item assignment. Okay, so it doesn't support the updation. Accessing is same as in case of this one. Delete also, you can delete the whole tuple but not the individual elements of the tuple. You can't make any changes to it. So insertion, updation, deletion of the individual elements cannot happen in case of tuples. Okay, it will throw you an error. Okay, but there is a way around. Like for example, I just want to insert a new element to this T1, 6. I just want to append 6 to it, right? One possibility is you can convert this into list. L1 equal to, how to convert tuple to a list? You can call a list object, list function, T1. Now you can L1 dot append, you can call 6. Okay. Now you can convert it back to a tuple. How to do that? Tuple of L1. This is redefining it actually. It's not updation, we call it, it's redefined. Okay. So like this you can do if you want to do it is necessary. All right. So that's all about the tuples. Updation, I mean, the accessing is same as in case of list, right? All that reverse indexing, forward indexing, slicing, everything is same as in case of list. Okay. Okay. Okay, we'll also cover sets, no? We have 5 more minutes. Why to waste time? We'll cover sets also. It's also easy concept. Sets. So we have used the bracket, square brackets for list, parenthesis for tuples. Do we have any more bracket?
Our bracket.
Curly braces.
Curly braces we use for sets and dictionaries also. Okay. So sets. Okay. So if you want to define a set, don't give an empty curly brackets. By default, it will take it as a dictionary. Okay. So just define some elements as well. 1, 2, 3, 4, 5. Okay. One more important property of the set is that set is unordered. One property. Second property is it has got the unique elements. Duplicate elements it will not allow. Even if I give the duplicate elements, it will not take them. It will take the unique elements of it. You can see that. So I'm just printing S1 now and type of it also. 1, 2, 3, 4, 5, and the type of it is set. Okay. So it only consider the unique elements. So various set operations like intersection, union, difference, whether one set is a subset of the other one or not, superset of the other one or not, whether they're disjoint sets or not, popping of the elements, all these operations on this sets also can be performed. Okay. So for example, let me take another set S2, which is some 3, 4, 5, 6, 7, something like that. Okay, so what is the intersection between S1 and S2? If I take the intersection between S1 and S2, what will I get?
3, 4, 5.
3, 4, 5, right? So let us take the intersection. I'm just printing the intersection. S1 dot intersection of S2. Okay, intersection of S2. Right, this will print 3, 4, 5. Right. Similarly, if you print union, then it will not make, please remember that it will not make any changes to the original list. It will just return that. Okay. So union. Then it will be 1, 2, 3, 4, 5, 6, 7, right?
Yes.
1, 2, 3, 4, 5, 6, 7.
So if we want to make the union of 3 to 3 sets,
Recursively you do it, madam.
okay.
Suppose if I take the S1 minus S2, you know the set difference, right? S1 minus S2, what it will return?
That are
1,
present
2.
in S1 but not
1, 2.
present in S2.
But not in S2. It means 1 and 2, right? Yes. Print S1 difference S2. This returns 1 and 2. If I give it in reverse order, S2 dot difference S1.
6, 7.
6, 7. All right. So is this superset of S1? Is S1 superset of S2? You can refer to that. Is it superset? No, right? Let me print. Set has no superset. Is superset. So S1 is not a superset of S2, isn't it? That's why it is returning false. Is S1 superset of this set 1, 2? True or false? Hello. True, right?
Sir.
True.
True.
Okay. Is S1 subset? S1 subset is subset of S2. Is it a subset?
No.
No, no.
No, sir.
False. Okay. Is it a subset of 1, 2, 3, 4, 5, 6? Or false?
True.
Yes.
True,
True.
sir.
False.
True.
True only, right? S1 is 1, 2, 3, 4. 1, 2, 3, 4, 5. And this is 1, 2, 3, 4, 5, 6. So
Yes,
S1
yes.
is a subset of this, right?
Yes.
Are the disjoint? Is disjoint? Is disjoint? Are the disjoint sets? No, right?
No.
There are some common elements, right? Disjoint. No. False. Is S1 disjoint of 6, 7?
Yes.
S1 disjoint, right?
True, true.
True. Right. Like this. You can perform various set operations using this. Okay. So these files are already shared with you on the Google Drive. You can go through them. Okay. So we'll discuss the next one more data structure dictionaries in the next session. So in this session, to summarize the session, we have covered what we have covered. What is data science? Why is it important? Who is data scientist? What he do? And what are the different applications of data science? And different domains are the parts of this data science, in which we have started discussing the machine learning. In the machine learning, we have seen what is learning, what is machine learning, what is the difference between the classic approaches versus the machine learning approaches, and what are the different paradigms of machine learning. We have seen supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, we have seen regression and classification. In the unsupervised learning, we have seen clustering and dimensionality reduction. Also, we have seen various applications of supervised learning, unsupervised learning, as well as reinforcement learning. Then we started discussing the Python concepts, in which we have discussed the data types and started discussing the data structures. Lists, tuples, and sets we have covered. In tomorrow's session, we'll also cover the dictionaries as well as the other Python libraries also we'll cover that are important in the context of machine learning and data science. Okay, that's all for today. If you have any queries, we can discuss. Otherwise, thank you very much and happy learning.
Thank you, sir.
Thank you, sir.
Sir,
Thank you.
sir,
Thank you, sir.
Yeah, any doubts you can ask.
Sir,
Sir, may I?
Yeah, ma'am. Proceed.
You
One of you.
mentioned you would be sharing the slides. I believe there's a WhatsApp group. If there is, I am not added there.
We have sent a mail, madam, to your registered mail ID. In that link to join the WhatsApp group is there. So using that link, you can join. Again, I will share, no problem. So you can join using that WhatsApp link. Once you join, I will share it again. So already few more people have joined. After I share it, I'll share it again.
All right, thank you,
Sir,
sir.
is it possible to share recording?
Yeah, recordings also will be shared.
Okay, thank you.